Hey, hi everyone. Today I want to talk about another microservice architecture topic, which is service per team. This is a slightly less talked about topic, I would say. I've seen people talking about how you can build an efficient microservice, but very few talks about the team structure and human part of it. Microservice is not just a, I would say, technical perspective. It's also human perspective. There's a business angle to it, why teams has gone to it. There is a very important business angles to it. I would actually talk about it. First, let's discuss what is microservices to be precise about it. So when you have a monolith service, which is nothing but everything written maybe in a single code base in a one place, you deploy it together, and you work with that. In smaller teams, it works perfectly. There is no issue with that. In smaller teams with smaller requirement, you should ideally go for a monolith, and this will help you build and scale your system well. If your requirements are smaller, you don't want a lot of extensibility to your service, it works pretty well. So you don't have to worry about it if you have a precisely concise system. But when your system grows, for example, you have some extensions, your business wants to grow, your team size wants to grow, at that time, it's highly recommended that you go for a design pattern, I would say, called microservices architecture. What you do over here is you divide your monolith into multiple microservices. How that works is basically you divide functionalities out of your monolith and create smaller services out of it, which actually does a similar job. And when combined together, they deliver the same outcome which you expected in the monolith to come. Then the obvious question may come is if everything was working fine in a monolith, why do we have to even extract things out, make it complex, and so on? So the answer is when you scale your system and you grow as a business, you have certain responsibilities which comes along with your business growing. One of the responsibilities is, or a couple of responsibilities I would say to your system is to scale well, to add new features as quickly as you can, and also you don't want any downtime of your system once they scale. Even when they scale, if something goes down, you don't want your entire system to go down. And especially your critical parts of the system, you want them to run always. In ideal cases, you want them to run 100% of time. So, if I had to give you an example, let's suppose you have an e-commerce domain and you are building an e-commerce, and there are multiple parts to it. Initially you build it in a single place, but eventually you realize that your business is growing. Initially you were not very sure whether the idea is going to work. There are already so many existing e-commerce sites. Why do I invest so much building these complex things in a complex way? You just wanted to try it out, and your experiment worked, and your idea shines. And then you number of users are keep increasing, and then now you need more people to work on. You want to match with the competitors. You want to introduce a lot of new features in your system as soon as possible. So you do two streams of work over here. One, you then adding you are adding a lot of new people, And when multiple people works on same piece of code or a service, the chances of conflicts increases a lot. Even to manage the teams or dividing the teams becomes very complex, because even if you divide the teams, they are going to work on the same service, and then that can cause a lot of problems. So the idea what comes in here is that you extract the teams, as well as you extract the component out from your system on which the teams can work. For example, there might be a functionality for search. So typically, there are generally three main portion of an e-commerce system which comes in the picture. One is the landing page, where the customer lands and sees some advertisement, some products which are recommended to them, some recent purchases and all. So one becomes a landing page to that e-commerce site. So what you do is you create a team, let's say landing team, and then you create a team of 4 or 5 people, including some BAs, QAs, and all. You have a team. Now, what you do is you extract the portion of that service which does that functionality. So, what you do, you extract that functionality, create another service. Eventually, it won't happen just like magically. So, you need some time to extract it. You need skilled people to do that, skilled developer to do that, who has done that in the past. So once you extract it, you make an independent team. Now they work on their own, and they eventually get to a point where they deploy their things independently. Now next step, what you do is you um, figure out another functionality. You can do it all together also. I'm just giving some examples. So you expect another stream of work where you say, my landing page is done. Now I want to search for a product. So you want to extract a team called search landing page, or and then you can have another team for product landing page, then another team for checkout, another team for payments, another team for let's say marketing and all. So and another team for a customer support maybe. So all those teams get divided, and then you extract out components out of your service, and then in a microservice architectural world, you then combine all them together, and then you work with them. So there are tools which comes in the market which can help you build those things, deploy those things, combining, and everything mostly is available now in the market. You might have heard of Docker, containerization, scaling, and all. Those are all coming out of these terminologies and real life use cases. It's not at all just theoretical knowledge, it's applied to any practically scaled system nowadays. So, one thing which we talked about is the people aspect of it, where there are a lot of people joining your team. You want to manage things independently. I'll talk about the advantages altogether later in this talk. But now let's get to the second problem. When the system was monolith and everything was there in the same bucket, I would say service. So the main problem was when multiple people start working, one thing which will be there will be a lot of conflict. Conflict means that you need some time to resolve them, and that takes time. Also, because multiple people are working in your business, the issue can come in any part of your system. And because you're deploying it all together, any part of your system, if it's broken, your entire system gets broken, because it's it's deployed, it's managed all together. So one failure in your system can cause the entire system downtime, and you don't want to do that. Suppose, for example, if for any reasons your landing page is not working, but you can at least search. There is some problem in the landing page, but you want to allow customer to search for products and buy it. Eventually, what is creating you money is people buying that product. You want to always have that part of your system up and running so that they never face a problem, at least when they want to buy the product. Suppose your messaging system is for any reason is down and you're not able to notify customer that your order is placed. Would that Should that stop your customers from placing an order? Not at all. They should go ahead, place the order, and then notification can come after some time. Even if that's down for some time, it's not a showstopper. That's what we need to understand. Now, when you segregated your system in multiple places and deploying it independently, they can go down at their own pace. And depending on the criticality of the system and the portion of the work that you are doing, you can choose to scale them. Suppose a day where you have a lot of sales, let's say in India we have big billion day sale, Diwali sale, and in Western countries you have Black Friday sale and all. And on those days the traffic comes uh, in a much larger volume compared to a normal business day, and you want to handle those traffic because that's where you generate a big amount of revenue for your system, for your business. So for those 2 3 days or for a week, you don't want anything to go down. And even if there are things to go down, it should not be interfering in between the process of buying the product. So you can choose to scale down some of the non so important portion of your system. Let's say you can scale down your landing page for some reason and you want to scale up the checkout system because you don't want anyone to come to checkout page and then they are not able to purchase the product. They will go buy from some other competitive sites because all of a sudden sales start on all the competitive sites also. So you don't want to lose the customer at the end of the process or even at the start. So you want to have the critical systems up and running, and because you assume the load will be there on that day on maybe search for a particular product or a particular page, let's say cart. Generally on normal days you don't get a lot of load on cart page, but on the sale days you will get a lot of load on cart. So you can actually scale them as per your need, as per your expectation of volume of customers and calls. You can scale the system well, and you can descale the system which are not very much needed. So it's a choice, and you see the flexibility which comes in the picture. So that's the business part of the reasons why you want to scale and do it independently in a microservices way more than the team. Now, let's talk about services per team. So, mm, because the domain is bigger now, the umbrella has lot of things to cater on now. What you want to know is you want to dedicate people and manager to the teams. Let's say there is a specific functionality which is coming in the cart, which says you want to show the products and some add-ons when they go to checkout page. Let's say I'm buying an iPhone. You also want me show the cover cases, some insurance policies to buy, and I want to do that in checkout page before letting the customer buy and so on for some business requirements. Now, this functionality goes directly to the checkout team. I can ask the checkout team, this is the functionality I want to implement, and because they know the service so well, the implementation would become faster. Now, at the same time, you may want to have a landing page team suggesting some products based on the recent purchases from the customer, so that you can ask from the landing team that, hey, this is the product I want to deliver, and they can in parallel develop both the functionalities. So you see, the development happens in parallel and nothing gets blocked. I'm not working on the piece you are working on, and you are not working on the piece which I am working on. We are working independently. We can take our time. There will be very few conflicts that will come. If they need help, they can reach out to any of them because the domain itself is one. And to share the context, generally what people do, they switch the teams and the people around. So that I have the context of the landing page also, but after 2 months, I want to also work on the card page. So that way, people are connected, the knowledge gets shared, and one or two or many people will have context of the entire system. And that reduces the one man failure scenario, because now you have multiple people working on different part of your system, and even if something fails and the person is for any reason is on off or they left the company, you don't have a show blocker. There are people who knows the system because they have switched between streams, and now they know the system one or the other way. So you see a lot of advantages of doing this, but in software world nothing comes without a trade-off. So there must be some trade-off to this also. So when we started, we were actually working with a single system. So managing it was like I would say theoretical wise, if you say, managing it becomes easy. Deployment was simpler because you were deploying just one system. If you have to scale, you have to scale just one. Now you have multiple systems interconnected, you have multiple teams to manage. If done well, they go very smooth. You won't find any better system, I think, as of today, which works well to this. But you have to cater to a lot of situations also. Now you need dedicated people who can do the deployments. You need to use fancy tools for deployment. Kubernetes, Docker comes in picture. You need to have scaling in place. You have to have messaging systems in place, and you need to tell them how they can connect internally. So the deployment process becomes a bit complex. It's a bit challenging, but if done well, they give you a hell lot of advantage, because your system is interconnected. You can cut the wires whenever you want. You can pull the wires whenever you want. So it comes with a lot of flexibilities, but it comes with a cost of deployment, multiple services, and when you scale, you will have mm, uh, an countless number of microservices that you can add up into your service. So you need to choose well when you want to actually introduce a new microservices. It's not that once you have adopted to a microservice architecture, any new things which we are building should have to be in a new microservice. We need to carefully observe where the system, where the piece of your works fits in, and just choose to put that in the right place. Don't just go and put because you are doing so. Because eventually, when you have a lot of things, a lot of microservices, managing them also can be complex. And if not done well, it will be worse than your monolith if not done well. And from the human perspective, I would say you need to have people who can take responsibilities when needed. And you can choose to give multiple services also to the team, because let's say card has a lot of work, but maybe search or landing page may not have a lot of work after certain time once they are established. So you can choose to give them multiple services to own. Once they are the owner of the services, they have the responsibilities to manage. They can do refactoring, they know the pieces well, they can extract certain things out, they can use different technologies and all. They can use even different languages to build different services. So all these comes with benefits and advantage. Let's say tomorrow there is a new technology comes specifically for an e-commerce world checkout page, and if you implement that, your system will go 200% faster compared to today. You want to adapt to that because your competitor will eventually. So if you are in a microservice way, you don't have to touch the entire system to migrate it. You can just build a new thing or migrate thing. You can plug and play. So you see the advantage without touching any other part of your system. You just build the new thing to the new language. You just insert it because the other system need not to know in what technologies or what things you have used to build that thing, and that's isolated. There are certain doors which has to be open the way they were previously, but the internals can be different. Once you enter in the house, you don't know what's coming, but you are like a postman. You just come to the door, you hand over the parcel, and you go back. You don't enter in the room and see what actually they are doing with the parcel. So that's what on the top level, on an overall structure, is happening. And you see the magic being happening. All the bigger systems, for example today Amazon, or any big system that you consider, even Flipkart, or any other system that has scaled, mostly they build are on microservices architecture. Even the team structure remains the same, and then the software development methodologies comes in the picture. You have agile teams which can adapt to new requirements well in advance, and you can keep growing to the market standards. So yeah, I think that was all for today's discussion. Hope this was helpful. See you in the next one. Thank you.